call summation notation. With this summation notation, first I've got to go over some other definitions first. That's kind of redundant. Okay, we defined the sequence the other day as these set of terms, and we just number them in order, 1, 2, 3, 4, fifth term, and so on. And it's called infinite if they keep on going forever. And 3 dots, I don't know if they've got 4, it should be 3, continues in this manner. And that would be an infinite, never-ending sequence. Now, if we find the sum of that, then basically we're saying the sum of all of these. Now we're just going to add them all, because sum means add. And it continues. Well, that's not possible, because we can never add to infinity. Okay? But we can add part of the way to infinity, which is where we're headed, which brings up what we call partial sums. Okay. Now we've got this sequence 3, 5, 7, 9, 11, whatever the sequence might happen to be. Okay. And it goes forever, never stops. But with a partial sum, we could say, how much do the first 10 of these add up to be? And that's kind of what we're talking here. And we would use the notation sum of the nth, saying how many that we wanted to add together. Okay, so then this would become this, ending with the highest numbered term that we choose to use. Good morning. Good morning. Okay, now this partial sum, this piece of that whole thing, will be a finite series because it has an ending point. We use the letter sigma, which in the Greek alphabet is our equivalent of S, capital S. Okay, which is kind of an irrelevant for what we're doing. We use that symbol to represent summations. You see this symbol, that means you got to add the stuff together. Okay. Now, the Greek symbol is used, and the way this is set up is this is the rule. Remember before we had a sub n equals some rule that we were evaluating? This is the rule for this. And we're going to evaluate from the first term to whatever this number nth term is. And that's what this is saying in this case. Okay. So we're going to find the sum of the first however many n is. This is called the index. Now, that is not an imaginary. Okay? This is the only time that you use an I, a small letter I, excuse me, in this mathematics, not as an imaginary, but it stands for the index or just its number in place. The 1 is the lowest number we're going to start with. It doesn't have to be 1. We could start with the third and go to whatever this one is. In which case, if we start with the third, that would be a 3. And then this is called the upper limit, or the highest number of terms we're going to deal with. Now, those of you who go on into calculus, you're going to have things called integral, which is operation on an equation, and you will have limits on those integrals. You're only going to evaluate them from this spot to that spot. In other words, you're limiting your range of x values in some cases in that case. So this is the idea of limits is something you're going to have to kind of get used to if you're going to go on into calculus. Now, this again is just kind of a restatement of what we've said. It would be impossible to actually do this to infinity. Okay, here's an example. Here's my rule. Basically, we're saying a sub n equals 3n minus 8. This is an equivalent thing to this, except now we're going to put in the fact that we're going to go from n would be 1 to n would be 3. Okay? So that's how this relates to what we've been doing. So this is the rule, and this tells what terms we want to add. Now, I'm going to show you the way they did it. Then I'm going to show you the way that I feel most comfortable showing the work for myself. Okay, here, if k is 1, oh, by the way, before they had an I, now they've got a k. You can basically use any letter of the alphabet you want, but I probably wouldn't use 0. I mean, O. And I just illustrated why. By the way, you guys know the difference in O and 0, don't you? Yeah? Well, O is when you stuck your toe and it hurts. And 0 is a numeral. Okay, another bad math joke. Oh, back to this. Here we go. The 3 replacement value of 1 minus 8. Well, ultimately, this is going to be 3 times 1 is 3 minus 8 is negative 5. Ultimately. Then we're going to do if k is 2. Because this notation means everything between 1 and 3 inclusive. So if k is 2, then we've got 6 minus 8, which is negative 2. And then finally, if k is 3, we've got 9 minus 8, which is 1. And if we add this negative 5, negative 7, negative 6, we'll get negative 6 for the solution. And then they've done what I did. But I was impatient. Now, I'd like to show you the way I prefer to do this problem. To do it. Now, you might think, well, what difference does it make? Not a bit. But sometimes you could end up with fractions up here with unequal denominators, and you'd have to convert them, and it's just a little easier in those cases. Okay. This layout is a little easier for some of the more complicated problems. But either way, we'll get the answer. Okay, so what is an arithmetic sequence? When you have a sequence, the relationship, when we call it arithmetic, that means that if I have the first term is 5, to get the second term, I've got to add some certain amount. Let's say 3. So 5 plus would make my second term 8. Then in turn, my third term would be 8 plus 3, or 11. And my fourth term would be 11 plus 3 would be 14, and so on and so on and so on. Okay, they have what we call a common difference. Now, the way you're really supposed to discover that difference or that amount of change is take the second one and subtract the first one. 8 minus 5 is 3. 11 minus 8 is 3. 14 minus 11 is 3. That's how you find what we call the common difference. Okay. And basically that just tells you how our sequence is going to grow. Now, this is math speak for what I just told you. Okay. This is the first term. That's the second term. If this one's 1, that one's 2. We take the second one and we subtract the first. Knowing this is not important. Just what I just told you. You take 1 and subtract the one that was before it. Okay. Now, what about the nth term? Meaning any term in the sequence. There is a formula for finding the nth or any term of the sequence. And there is the formula. Please open your handout package to page 30. A sub 1, of course, is the first term in the sequence. D is the common difference we just talked about. And then whatever term you're wanting, minus 1 times the D. And that will give you whatever that term is. We'll go over it in a moment. Now, let's look at this example. By the way, I think I've skipped the slide. I should have had. Oh, I think, didn't I already tell you to put these on page 30 and page 32?
Yeah.
Okay, I was looking for that sheet where I told you to do that. All right. Now, I've got this sequence. They're asking us to do 2 things. One is they're trying to ask us, is this an arithmetic, by the definition we gave you, is this an arithmetic sequence? And if it is, then they want us to find the common difference. Well, if we look at this first one, 3 minus 1 is 2. But 9 minus 3 is 2. So this one is not an arithmetic sequence. So we can't find a common difference. This one, on the other hand, 9 minus 4 is 5. 14 minus 9 is 5. 15 minus 14 is 5, and so on. So we have a common difference of 5. Okay. Here's the arithmetic showing those. That one is not, and this one is. and that our common difference is 5. Okay, here's another one. Is this arithmetic? 5 minus 12 is -7. -2 minus 5 is also -7. Minus 2 is -7, or minus sign -2, and so on. So yes, this is common difference -7. Okay. Notice when I had the negative common difference, my term values were going down instead of up. What about it? 4 minus 1 is 3, 9 minus 4, won't work. Okay, that one won't work. Actually, that's the list of perfect squares. N squared is the rule for that one. If you want to make that little note. Okay. Now, write the first 4 terms of an arithmetic sequence. Let me back that up one. Well, I can. Of an arithmetic sequence with the first term is -2 and a common difference of -3. Okay. So we're going to have a diminishing sequence. It's going to get smaller, lower numbers as we go from term to term to term. Okay. Now, in this case, it tells us that the first term is -2. So the second term, we have to use this formula. We have to use this formula. This formula says you take the first term plus, and they didn't show this step up here, so I will, n is 2 in this case, -1 times d, which is -3, okay? This is what they didn't show right here. 2 minus 1 is 1, and 1 times -3 is -3. That's where that came from. So 2 plus -3 is -5. Would be our term. Okay, then we continue. We're going to find the third term. Here we have now they're doing this recursively where we're continuing with this. Again, they're skipping in here. In this case, 3 minus 1, 3 minus 1 times -3. Okay. Oh, this is third term, not second term. Yeah, 3 minus 1. So you should get 2 times that -3. And in this one, they're doing something a little bit differently than they should. Okay. They're using this format right here, building on terms. They're taking term plus the difference. Then they're taking the third term plus the difference. That's another way compared to starting all over from scratch. Okay. So way of doing this. Here is the way the fourth term, common way. I want you to get in the habit of showing it. Okay. You see, we get the same answer either way. N minus 1 here, first term. So in that case, your sequence then would have been -2, -5, -8, -11 for the first four terms. Okay, let's look at this one. This is done the way that I prefer it. Okay. Write the first terms with the first term is 8. A sub 1 is 8. Common difference 83. So for the second term, n is 2. I have first term plus 2 minus 1 is 1 times 83 gives me 8 plus -3 is 5. For the third term 3 minus 1 times the common difference gives you 8 minus 6 is 2. The fourth term, 2 plus, and in this case, we would have 4 minus 1 is -3 times that. And so here is our sequence. And we could keep on if we wanted to even farther. Find the 23rd term of this. This is something new now in terms of how we're doing it. Find the 23rd term. We don't have to do all of them in between on this problem. Since we know the first term, we can find the common difference here. -3 minus -8 is -11. So our common difference is -11. So on this particular problem, -3 minus -8, duh, my mistake, is 5. I'll have to edit that out of my video probably. Okay, so anyway, common difference is 5. So here's our formula. If we want to find the 23rd term, then we put in the first term. We're going to put in this 22 comes from 23 minus 1. And 22 times 5 is what, 110? And -8 gives you that. So we've got 110 here. And so we end up with 102 would be the 23rd term in this case. Find the 40th term. You do this one. Here's your formula. We're finding the 40th term. Colin, if I'm getting in your way, let me. Well, we got to find D. Okay. It tells us 2 terms, but we don't know D. But look how far it is between those 2 terms it gives us. So if this is the first term, and that's that one, well, let's see what happens. In this case, n, for that one, n would be 11, right? So if we take this form, we're going to put in the first term, we're going to put in the 11 for the 11th term. Okay. To find the 11th term, we're going to put in the first term, 11th, the 11th number for that term, 11 minus 1 is 10, times d, our common difference. We know that the 11th term is negative 38. Okay. We know the first term is 12. Figure out from this 11 minus 1 times d that we've got 10d here. Well, that's an equation to solve. Take the 12 over to the other side. Divide both sides by 10. And we've got a common difference of negative 5. So sometimes you have to algebraically figure out what d is. But this is how you do it. You put in the term number here, and then you put in the term value here using this equation to solve for d. Okay. Once we know the d, we can now find the 40th term. How big is that 39? Well, 40 minus 1. Okay. And a sub 1 should be 12. And d would be negative 5. And your answer then is negative 183. Would be the 40th term in that particular sequence. So we've got two distinct parts of this problem. The first part of this problem is we're finding out what d is. Then once we've got d, it's just a standard problem. Well, we don't have to do the application problems any longer. Find the 10th term. It gives you the first term and it gives you the 30th. The process on this one is exactly the same as we did on the last one. We got to solve for d first. So we put in the value of the 30th term. Here is the first term. And this 29 comes from 30 minus 1. And then we don't know d yet. We take the 12 over, get 116 equals 29d, divide both sides by 29, and we discover d is positive 4. In the same manner we did last time. Now this becomes a conventional problem with this formula. We put in the first term, and we want to know the 10th term. 10 minus 1 is 9. And d is 4, which gives us a total of 48 for the 10th term. Any questions on this one or the last one? what they're telling us this time is 98 is the last term they're going to figure out. What they want to do is find out what term number that 98 represents. So we're going about this from a little bit different perspective. In this case, we do have the two terms, so we can get the common difference. So 8 minus 3 is 5, so our common difference is going to be 5. Our first term is 3, and we know the answer to our last term is 98. We just don't know what number place it is. So here's our formula. Let's put in what we know. We know the value of this is 98. We know the value of the first term is 3. We don't know the number, so we've got to leave that abstractly. And we do know this. Well, we can distribute this 5, giving us this equation. Take this 5 over, take that 3 over, and we get 5n equals 100. We're going to add 5 to both sides and subtract 3 from both sides. And anyway, we get 5n equals 100, 20 nickels in a dollar, so n equals 20. Now we have everything that we know. We now know that that is the 20th term. And we could prove it going the other direction now if we wanted to. Okay, this one. This one, we're going to use that alternative formula that I had you write on page 30 and page 32. Okay. In this case, they give us the common difference. They give us this term, and they give us that term. Okay. They want us to find the 16th term, or a sub 16. They give us this, they give us that. They didn't necessarily give us the first term. But what we can do then is we can use this modified formula right here, which this stands for the 13th term in this case. Here's our common difference of -7. Here, we're going to take the n minus 13, and n in this case is 16. So 16 minus 13, which I've got shown right up here. So that is this information put in here almost, except the 13th term is 9. Common difference, -7. And 16 minus 13, again, the 16 here for n minus 13, okay, which is there, gives us this 3. So we got 9 minus 21, which gives us -12. So the 16th term then is -12. Now, when do you use this alternative one? We don't know the first term. Okay. We know some term in the middle. We know its value. Other term we want to know. That's when you use this alternative formula. Okay. You can put these into word problems. Now, to a finite series, evaluating. That means how much is it worth? Okay, they're using the word series now, not sequence. That means we're going to be adding these terms. Okay. So we talked about partial sum, what it was before. Now we're actually going to deal with it. I introduced the definition of a partial sum earlier. Here again. The formula, deal with it. Now I've had that on the bottom of all of my formula here in the corner, and it's also right here on page 3. Now I'm going to tell you what this formula really is. What does that part right there look like? Add them together and divide them by 2. What's the word for when you do that? Average. Okay. What this formula is we're taking the total number of terms times the average of the value of the first term, the last term divided by 2. That's what we're doing in reality. By the way, this used to be a question that they would always put on the National Quiz Bowl for middle school contests. This particular question is if they give you a series of numbers and they tell you what the first value is and the last value is, what is the sum of all of them? And that was the trick to do it. Well, let's go ahead and work this. A sub 1 is the first term of the sequence. I think it just died. That would be sad. How about that? Guess I'll have to use my fingers more. Okay, so anyway, A sub 1 is the first term of the sequence. A sub n is the last term. And I wonder if the clicker will still work. Well, now it's working. Except I kicked myself out. Nothing like technical problems. And I think that's where we were. Okay, so here we go. In this case, find the sum of the first 25 terms of a sequence that starts off like this. Okay. Well, we can do that. And what are we doing here? Well, here's the first term. Common difference is 4. For the nth term, which we don't know in this case, we don't know the nth term, so we got to figure it out. A sub 1 plus n minus 1d. So the term is going to be ultimately 25, and then 4. Now, in this case, distribute this, and we get 4n minus 4, and 3 minus 4 make minus 1. Skipped a step here. Maybe I better put that in. What's going on with this thing? Now, In this case, we've got 3 plus 4n minus 4, and this give you that. So, and now we take this and put our fifth term there. What we have done here, and you need to know this because this is a repeatable, testable item, is we have discovered the rule for this sequence. We have discovered the rule for this sequence. And this is the process that we use to do that. Now, so we have this, 4n minus 1 is the rule. So we put 4 times 25, because they want to know the 25th term, minus 1. Well, 4 times 25 is 100, minus 1 is 99. So in that case, the 25th term then is 99. Now that we know the last term, we can use this equation. Okay? Because we now know the first term, we know the last term, and we can use this formula. And we also know that the last term is the 25th term. So we can use this formula to find the sum of all of these values up through 99. Well, here we're just going to sub and solve. 3 is the first term, 99 is the last term, and 25 is the total number of terms, and we're going to divide it by 2. Okay, 3 plus 99 is 102. Half of 102 is 51. 51 times 25 is roughly 670 or something. No, way wrong. Anyway, it works out to that. This is the point where you get your calculator out. Actually, all you'd need to do calculator for would be by 25 times 51. Question on this one? On this one, we're not actually going to work this whole thing out, but you do need to know that the common difference is 2, a sub 1 is 1, and so on. A sub n, we would solve this just like we did in the last problem. Okay. We write the formula, and for some reason I wrote my n backwards. I guess I'm dyslexic today, or the day of that. So anyway, I distribute this to, so I get 1 plus 2n minus 2. I combine the 1 and the negative 2, so I end up with 2n minus 1 is my rule. Now I can put in the 50th term here. A sub 50 equals the first term times 50 minus 1 equals 99. Conveniently again. So if 99 is the 50th term in this case, now we can go through and find the sum of them using that formula. So we're going to take 1 plus 99, which is 100, divided by 2, and take that 2 times 50, or that 25 rather. 50 times 2 is 25, and that's 100. And you get 25. Big. But you see the process on this one. We substituted, got the rule. Then we picked whatever number we wanted, put into the rule, and got the last value, the nth value. Okay. Then we were able to find the sum of them. Geometric are different from arithmetic in that you multiply or divide by some number, some common factor, which they're going to use the letter R for ratio. Ratio is just a fractional thing. Now, a ratio of 2/1 would be just 2. So, you know, this R can be a whole number, or it can be a fraction, either way. Now, find the sum of this finite geometric series. You've got a totally different formula for that. The first term times the common ratio, meaning how do you multiply from one number to the next to the next, to the n minus 1 power. Now that's your formula for that one. In this case, we find our common ratio. How do we go from 3 to 6? Well, 6 divided by 3 is 2. 12 divided by 6 is 2. Okay? In arithmetic, we subtracted the first from the second. Here, we divide. We take the first divided by, the second divided by the first to get the common ratio. I've got to say that in the right order. This one divided by that one, or this one divided by that one, always one before, just like we subtracted before for arithmetic. And that will give us our common ratio. In this case, our common ratio is 2. So that's what we put right here in this formula. So we now have enough stuff almost to work this problem. The only problem is we don't know what n number that one is. Okay. Well, the first term would be this. We put the 3 in there. We put the common ratio. We have the power. Okay. Now, if we put that value in here, that gives us the value of whatever the nth term is. Looks like it's time to buy a new pointer if every time I set it on the tray, this thing falls apart. Okay, now, what we're doing here, this is the nth term. Okay. So we're replacing this 1536 with this a sub n. Here we got our first term. Here we got our common ratio, and then here we have our power. Now, in this case, we need to manipulate it kind of like we've been manipulating exponential equations this semester. First thing I did was I divided both sides by 3. So I got a pure exponential equation. It just so happens that 5, 12, 2, 4, 8, 16, 32, 64, 128, 256, 512 happens to be 9th power of 2. Makes it pretty convenient. Okay. So we've got this. We can extract both bases, leaving the equation 9 equals n minus 1. Add 1 to both sides, and we get n equals 10. So now we are saying that this equals the 10th term. Now that we know that, we can use this formula, and it wants us to find the sum. Well, that's not the sum formula. There's a different formula for the geometric sums. Okay. Again, here's our information. This is the sum form. Now, before I start this, I'm going to tell you there's a different way you can work this problem. Okay, so here it is. First term, 1 minus that to the nth power over 1 minus the 2 in this case. That 2 there. So we substitute in, use your calculator, and get that value. Arithmetic, add 2 every time. Geometric, multiply by 2 every time. Okay? Well, find the sum of this geometric series. Okay, you can do that. You don't know what that nth term is, its term number. So we've got to go through this business to figure it out. 768, I'm using formula. 768 equals 3, the common ratio, okay, or the first term rather, and 2, 3 times 6, 6 times 2 is 12, and so on, okay, or 6 divided by 3 is 2, 12 divided by 6 is 2. I've got those 2, and then I've got my n minus 1. Both sides by 3, you get 256 equals 2 to the n minus 1 power. 256 is 2 to the 8th power, conveniently. So we can pull the bases and get a equals n minus 1, and n equals the 9th term. Now we can use the sum formula for geometry. And here it is. First term, 1 minus r to the nth power, 9 in this case we've calculated, over 1 minus r comes 81 in the denominator, comes 1 minus 512, and 3 times negative 511 over negative 1. Ultimately, these two negatives are going to cancel each other out. So you'll have 3 times 511 is 1533. What that 1533 is the amount, if you added all of these from here to there up, what you would get. Okay, anyone not ready? Okay, this is just rewording what we've said, right? Okay. Geometric sequences grow this way. Let's say in that problem a moment ago that r was 2. Okay, multiplies by 2 each time. So if this first term is multiplied by 2, you get that. The next term would be multiplied by 2 again, and you would get that. And the next term you would multiply by 2 again, and you would get that. Okay. If this, well, at least I'm here. If this were 2, then if the common ratio is 2, then this one would be 4, right? Well, this one would be 8, which is this, and then times 4, which 2 squared would be 4, so 2 times 4 is 8. This is 8, so 2 times 8 would be 16. That is 16, so 2 times 16 would be 32, and so on. That's what this notation really means. As you go on 1, your r actually increases by a power each time. And sometimes knowing that can be a useful one. And then you've got, basically because of that, you've got this term that equation that we can use. Okay, let's try this. Here, we've got this geometric equation. We're multiplying by 3 each time. R is 3. 6 divided by 2 is 3. 18 divided by 2 is 3. 54 divided by 18 is 3. It's 3. Determine if it's geometric. Well, we just did. Okay. Identify the common ratio. Well, we just did. On this one, 6 divided by 2 is 3. 10 divided by 6 is something different. Well, by the way, this one is. That one, 10 divided by 6 is a different value. 14 divided by 10 is a different value still. That one is not geometric. That's all this is testing to see if it's geometric. Now, write the first four terms. If that's the first term and the common ratio is 4, write the first four terms. Okay, there's the formula. Okay, we're going to put in the first term, the common ratio, and then whatever n is. So if we want n to be 2, well, n equal 1, we already know, but this just proves it. For a equal to n equal 2, n minus 1 is 1. So that would give you 4 times negative 2 is negative 8. N minus 1, 3 minus 1 is 2. 4 to the second is 16 times negative 2 is 32. Here again, we have 4 minus 1 is 3. And we get 128, and then we can graph these if we wish. And this will be the last slide that we're going to do today. Write the first 5 terms of this geometric sequence. They give us the common ratio, they give us the first term. So basically all we have to do is use this formula repeatedly. Okay, first term is 2, done. Second term, 2 minus 1 is 1, so 2, that's negative 3 times 2 is negative 6. For the third term, 3 minus 1 is 2. Negative 3 squared is 9 times 2 is 18. 4 minus 1 is 3. Gives you negative 27 times 2 is negative 54. 5 minus 1 is 4. Gives you 81 times 2 is 162. So your first 5 terms are negative 16, 18, negative 54, and 162. Notice in this case, you have an alternating sequence in here. You have an alternating sequence. Why? Because we've got a negative number to a power. Remember that from before in the arithmetic? That's why. And you need to be alert for that. Okay. And that's where we'll stop. Have a good weekend. Do your best. We've covered everything.